Welcome to Algebra 2. Today we're again introducing Chapter 3. This is 3.B, we're calling it, Solving Quadratic Equations by Factoring, Part 2. A little bit more difficult factoring work done today. But after this, realize that we will have the means with which to solve any factorable quadratic available to us. So a big step. Again, still a review of Algebra 1, so hopefully this will go pretty quickly. In lieu of an actual introduction that is just me typing something to you, I figure we can take an annotated example to approach this concept. So let's go through the process. The point is, what do we do when there now is an a value that's not 1 in our trinomial, in our quadratic? So you can see an example of that here. We've got 4x squared instead of just x squared. All right, well, first of all, once we have our trinomial all established, if we're solving an equation, we've got it set equal to 0 to begin. Then we do this. So step 1 is to take a times c. All right, so when I do that, in this case, 4 times 3 is 12. Step 2 is to then find the magic numbers, and this is just an adjusted approach. From what we had earlier. Because of that 4 out front, we needed to involve that in our magic number process. So what multiplies to be 12, and we're still going to look back at that b term in the original, and adds up to make that. So in this case, my magic numbers, I'm going to jot those off to the side, are 12 and 1, both positive. Step 3, I call that just the skeleton. We're going to make a skeleton of what factors look like when we unfoil. So I've got something x and then some number afterwards, something x and then some number afterwards. Step 4, and again, I'm really breaking it down. You're going to find that this goes very, very quickly after you've practiced it a few times. Okay? Step 4, I call it set the outside. In other words, we're going to set this outside in our quote-unquote FOIL process. We're going to use that to arrive at our factors. So to do that, I need to think, what could multiply into a 4? What are the factors of 4? Numbers that divide it cleanly, 1, 2, and 4. Also, what are the factors of 3? 1 and 3. So to set the outside, I'm going to pick the easier of my magic numbers. It's 1. And I'm going to say, how can I take a factor from this 4 times a factor from that 3 to produce that magic number of 1? So I want to make a 1 out of that outside. Well, the way I do that is to take the 1 from the leading term, that goes on this x, and the 1 from the trailing term. So I've got 1x something, and then at the end, positive 1 in my second factor. All right. And then step 5 is to finish by thinking through FOIL. So first times first had to make 4x squared. That's 1x times what? This has to be a 4. All right. Then last times last, that had to make a 3. Something times 1, that has to be plus 3. Okay, and then lastly, step 6, because right now you can see we've got it all factored out. Step 6 is to check with the inside. So we started with the outside. That product made our positive 1. If I check with the inside, 3 times 4, hey, that makes 12. It should make your other magic number. Right? So you can see it's a very fast process once you get the steps down. And once you know what to look for, you can go very quickly. There's not much writing involved. It's actually a really, really nice procedure. So let's look at a couple examples here. For the first one, I'm factoring this. Let's do a times c. I noticed that 4 out front, so I have to involve that. I get negative 12. What multiplies to be negative 12 and adds up to this positive 4? That's our b term in the original problem. Well, okay, that would be positive 6 and negative 2. I'm going to set up my skeleton of factors here. And my easier magic number is negative 2. So I've got 1, 2, 4 to work with from that leading 4, and I've got 1 and 3 to work with from that negative 3 at the end. To make a negative 2, I'm going to take the 1 from the 4. Oh, not the 1 from the 4. I'm going to take the 2 from the 4 and the negative 1 from the 3. So I set the outside numbers first to make negative 2. Then first times first had to make 4x squared. That's 2x times 2x. If I were to think of foiling, last times last has to be negative 3. That has to be positive 3 times the negative 1. Let's check with the inside. I've got 3 times 2. Hey, that makes 6, my other magic number. We've got that one done. For letter B, 2x squared, I've got to do a times c. I get negative 14. What multiplies to be negative 14 adds up to negative 5. It's negative 7 and positive 2. Let's set up our skeleton of factors here. Something x, leave room at the end of each. The easier factor is the 2 to work with, so I'm going to make the outside combine to be 2. Pretty nice that we got 2 and 7 that are both prime numbers. I just take the 2 and the positive 1. Okay, first times first has to make 2x squared. That means that had to be a 1x. Last times last makes negative 7. That had to be minus 7. Let's check the inside. Hey, it makes a negative 7. We've got that thing factored. Now, be aware that there are some factoring gimmicks and things that you may have been taught in other classes. I prefer this method above all those. Some of those are pretty quick and they're pretty nice, but I really like the fact that this relies on FOIL. You can see that we are literally unfoiling it. We're using the steps of FOIL kind of in reverse in order to set up our factors from the original trinomial. I really like the connection between those two processes that this allows. All right, and our final set here, now we're going to solve by factoring when we have a not equal to 1, these complex trinomials. First step, make sure it's set equal to 0. We've got that in letter A. Let's get going. 6 times negative 8 is negative 48. Let's find our magic numbers. They're negative 16 and positive 3. Let's make a skeleton for our factors. The easier magic number is 3. We've got a lot of factors that go into that leading 6 and that trailing 8. To make a 3, I'm going to take the 3 and the 1. So that's going to make up my outside 3x and positive 1 to make that positive 3 for a magic number. First times first has to make 6x squared, so that must be a 2x. Last times last has to make negative 8, so that must be minus 8. Let's check our inside. Sure enough, negative 8 and 2 make a negative 16. We've got that thing factored. Ooh, I'm not done yet though. We're solving by factoring, so it's set equal to 0. Let's finish this up just like we did yesterday. Each factor, where does that 0 out? So 3x minus 8, if that were to equal 0, that first factor, I would add 8 and divide by 3. X equals positive 8 over 3. Second one, if 2x plus 1 were to equal 0, I would subtract 1 and divide by 2. X equals negative 1/2. Very, very fast. Not that much extra writing on our part once we have this down. I can't stress enough, don't be discouraged if it takes us a little bit of time to figure out the nuances of it. You give this some time, it will pay back big time. For letter B, we've got to get it set equal to 0 first, so I'm going to make sure I set that into standard form, just subtracting 3 from both sides. 6x squared, so I have to do a times c, that's negative 18. What multiplies to be negative 18 and adds up to that positive 7 that's on that middle term up above? Well, it's positive 9 and negative 2. Let's set up some skeleton factors. I'm going to make sure I remember it's set equal to 0 this time. The easier one to work with is this negative 2. How do I make that negative 2? Well, I take the 2 and the 1 from my leading and trailing terms. So I've got 2x and negative 1 to set my outside. First times first has to make 6x squared, so that must be a 3. Last times last has to make negative 3. That must be plus 3 in this factor. Okay, if that first factor were set equal to 0, I would subtract 3 and divide by 2. If the second factor were set equal to 0, where does that 0 out? I would add 1 and divide by 3, positive 1/3. Again, you can find yourselves becoming quite automatic with this if you give it a little bit of practice. Can't stress that enough. The practice is important because it really does take like 10 or 11 problems of this to really appreciate and witness the efficiency of it. For letter C, if I put that into standard form, I'm going to add 6x squared to both sides, and that has to be the leading term. We need the x squared term out front, and then the regular x term in the middle, and then the constant at the end. That has to be in standard form for this to work. All right. A times C gives me 36. What multiplies to be 36 adds up to 13. Those magic numbers are 9 and 4. Let's set up our skeleton factors. Something x, something x. I'm going to choose to make the 4 first. So I've got 1, 2, 3, and 6 to choose from for the first term. 1, 2, 3, and 6 in the second. And that constant at the end, that positive 6. To make a 4, I'm going to take 2 and 2. So my outside product is going to be 2 and 2. Set the outside. Let's complete FOIL. First times first has to make 6x squared. This must be a 3. Last times last has to make positive 6. That must be a 3 as well. Let's check the inside terms. 3 times 3 is 9. By God, that's our other magic number. It worked. Lastly, let's imagine we were setting this factor 2x plus 3 equal to 0. To solve, I would subtract 3 and divide by 2, negative 3 halves. Let's imagine we were setting the second factor equal to 0. Subtract 2 and divide by 3, negative 2/3. Right. And finally, letter D. Again, we have to go through the effort to set that equal to 0 ourselves first. That means adding 15x to both sides, and be sure that that 15x goes in between the 4x squared and the 14. We need that standard form in order for this method to work. A times C is 56. What multiplies to be 56 and adds up to 15? Those magic numbers are 8 and 7. Okay, set up some skeleton factors here. I'm just going to slide this recording video out of the way. The easier magic number to work with is the 7. I've got 1, 2, 4 here. I've got 1, 2, 7, 14 at the end. To set my outside and make a 7, I need the 1 coming out of this leading 4, and I need the 7 coming out of that trailing 14. First times first has to make 4x squared. That must be a 4x in my second factor. Last times last has to make 14. That must be plus 2. Quick check of my inside terms, 2 and 4 do in fact make 8, my other magic number. We have factored that correctly. Let's grab the solutions out of that. For the first factor, I would just subtract 2 from both sides and I'd be done. So x equals negative 2 is one of those solutions. And if this second factor were set equal to 0, I would subtract 7 and divide by 4. That's how I would solve for x. Negative 7 divided by 4. Negative 7/4 is that answer. All right, so there you have it. That's the kind of revisiting of the factoring that we probably learned in Algebra 1. Maybe we practiced it a bit in geometry, but I really think that if you give this some time, you're going to become very, very efficient with it. I have a little saying that I like to say when we're solving quadratics, to factor is faster, so try to factor first. This is so fast, we don't want to just dive into quadratic formula that we'll learn later this chapter. Revisiting this and knowing this well is a fantastic skill to have as we look ahead to chapter 3. So please treat this with a little bit of reverence because it will help you out greatly, not just here, but in future math classes as well. Yet again, your assignment for this section is a worksheet. Again, give this some time, be patient with it, learn the steps because it will pay off greatly. Can't stress that enough.